Today's topic is spectroscopy. Introduction. The spectroscopy is the measurement and interpretation of electromagnetic radiation, otherwise it called as EMR. Here the principle are absorption or emission. When the molecules or atoms or ions of a sample moves from one energy state to another energy state, how can we tell that means from ground state to excited state or excited state to ground state. At the ground state, the energy of molecules is sum total of rotational, vibrational, electronic energies. In spectroscopy, the measure changes in vibrational, rotational, electronic energies. The EMR, which is also called as electromagnetic radiation, is made up of particles called photons. The electromagnetic radiation has got both wave characteristics and as well as particle characteristics. The measure of travel vacuum also have been measured. There are types of electromagnetic radiations like ultraviolet radiation, microwaves, IR radiation, radio waves, X-rays, gamma rays, cosmic rays, etc. Here we have seen the electromagnetic radiation energy equation, which is E is equal to hv. Here comes where E is the energy of radiation, h is Planck's constant, and the V is frequency of radiation, and the frequency is divided by the c by lambda, which is none other than velocity of light in vacuum called as c. Lambda means which denoted as wavelength also denoted by the lambda. Here comes the equation E is equal to hv is equals to hc by lambda is equals to hcv bar. The energy of radiation depends upon the frequency and wavelength of the radiation. Frequency. The definition of frequency is wavelength, complete wavelength passing through a unit time at a point. The wavelength is denoted as particular time, certain point. The wavelength of a drug which is passes through in number of times, that will called as frequency. Here we can observe the frequency is the number of complete wavelength. Sum of wavelength number is called as frequency, which passes through a given point in unit time. The frequency is measured in hertz or cycles per second. Here wavelength definition also there. The wavelength is distance between two successive maximum or minimum distance between two successive peaks, which are from ground state to excited state, or we call as ground state to excited state and excited state to ground state. Here we observe the diagram and it will shows the distance. Here we can observe the frequency and also wavelength. The frequency is which is the total number of complete wavelength units passing through a given point in unit time. The wavelength is the distance between the maximum and minimum successive peaks. We can easily find this, we can easily understood by this diagram. Wave number we denoted by the number of waves per centimeter. Okay, here The wavelength can be measured in meters, centimeters, millimeters, and nanometers. The wave number is expressed in kSer or centimeters inverse. Wave number used in infrared spectroscopy, because of the small wavelength measurements are made in that infrared spectroscopy, so we have to use the different frequencies of vibrations in molecules. Here the main topic is another types of spectroscopy. Spectroscopy is conveniently divided into the following types. They are, which is types of spectroscopy: atomic spectroscopy, molecular spectroscopy, absorption spectroscopy, emission spectroscopy, electronic spectroscopy, magnetic spectroscopy. These are the types, and here each one I can give an example, and I can define the each spectroscopy type. Here first, atomic spectroscopy is change in energy changes in atomic level. Example: absorption spectroscopy, flame potentiometry, and atomic absorption, atomic emission of radiation. These are the examples. And molecular spectroscopy means changes in molecular level. Easily we can understood the spectroscopy types because of the absorption. Changes in absorption is called absorption spectroscopy. Changes in emission is called emission spectroscopy. And changes in electromagnetic radiation it called as electronic spectroscopy. Changes in magnetic field which known as a magnetic spectroscopy. Likewise, these are the 6 types of the spectroscopy: atomic spectroscopy, molecular spectroscopy, absorption spectroscopy, emission spectroscopy, electronic spectroscopy, and magnetic spectroscopy. The energy of